think we're good to get going. Well, hi everyone, thanks for coming along. My name is Dave Fellows, as it says there, CTO at GreenButton. I joined the company beginning of last year as the chief architect to rebuild the solution from a Linux-based platform to Windows Azure. So that was a fun job, and here's where we are today. So we launched the service back in October on Windows Azure. So I'll take you through a little bit about what we're doing, show you some demos. But first I want to start with a bit of a story, and I want to go back to the year 2003, if we can, to when Weta Studios in New Zealand were producing the Lord of the Rings trilogy. Let's see if my clickers stop working. Excuse me. Here we go. So yeah, it was 2003, and there was only 2 months to go until The Return of the King, which is the final movie in the trilogy, as we know, was due to launch. And Peter Jackson had just called the special meeting to review some of the latest scenes. And so he pulls up some low-resolution drafts of the Battle of Pelennor Fields. I'm sure you guys remember the one where you got the riders of Rohan charging down the hill to meet the orcs in front of the city of Minas Tirith. Something like that. And so in these scenes are hundreds of thousands of digital orcs and tens of thousands of riders of Rohan. And each of these characters is actually individually generated and rendered and then placed on the battlefield. And so just to render a single frame is going to take days. Now, our founder, Scott Houston, was a CTO at Weta at this time, and his jaw literally hit the floor because their data centers were already running at full capacity. You know, there's no way they were going to be able to do this and get the film out in time in 2 months' time. And so him and the technical team, they got around and did some calculations on the back of a Siggy packet. And he went up to Barry Osborne, the producer of the trilogy, and he said, "Barry, you've got two options. We can build a brand new data center with 1,000 processors in 2 weeks, and we should be good." Scott, that sounds terribly horrendous. What's option 2? Well, you can tell Peter Jackson he can't have his shots. So apparently that's not something you want to do, and they went ahead and built a brand new data center. They had IBM put the Blade servers in a private jet and whisked to Wellington, IBM's largest customer at the time. And they had a helicopter dropping kit to the site daily. It was a massive operation. And they got this data center built in 10 days, which is pretty incredible. And they got the movie out in time. But the extra cost and effort involved, you know, for $5 million to build this data center, for less than 2 months' work, is just nuts. And what has this got to do with the GreenButton? Good question. So when the movies were over, Weta no longer needed this extra capacity. And so Scott left there and formed a joint venture called the New Zealand Supercomputer Centre and marketed this extra capacity as to businesses in New Zealand and Australia. And at the time, it was actually the second largest on-demand computing facility in the world, behind IBM's Deep Blue facility in Poughkeepsie. And so they had a lot of success running up 3D seismic imaging jobs, DNA sequencing, ran some local productions like Happy Feet. But for every large job they ran up, there were like dozens of smaller jobs where it just wasn't economically viable to load the data up, manually provision the environments, handhold the job to completion, and get it back to the customer. And so Scott really thought, you know, there has to be a better way, and he came up with this concept of the GreenButton as a way of providing a seamless interface to on-demand capacity and manage all the transfer of data and the provisioning of the environment. And so they built the software on the New Zealand Supercomputer Centre on this Linux-based system and had a lot of success with that. But then, beginning of last year, Microsoft called us up from Redmond and said, "Hey, we've heard about this GreenButton stuff. You want to do a project with us and bring it over to Windows Azure?" And it was really good timing because at that stage we were looking for a global public cloud provider to really take the solution to the next level. So we're going to talk about that today, but the key thing I want to show you is that the GreenButton allows you to access the power of a supercomputer from your desktop, all at the push of a button. And so firstly, I want to briefly touch on some of the problems that customers have faced with high-performance computing today, and then we'll have a look at how the GreenButton solution addresses those challenges. And we'll touch on some of our experiences and insight that we've had working with Windows Azure and the cloud, and we've got some demos along the way, so fingers crossed everything behaves. So the problems of high-performance computing, well, firstly, anyone you speak to, they're going to tell you, you know, it's extremely expensive. You know, the hardware is expensive, the management software is expensive, let alone the software that you're using to run your particular analysis. Secondly, it's extremely complex, as this young man knows. He's trying to do it on a white blackboard. There's a fundamental problem that underpins this cost and complexity, and that's the stuff just takes too darn long. You know, whether you're crunching DNA or rendering a film, you know, it takes a heck of a lot of compute, and so this drives this cost and complexity. And so these are the problems that we look to address. You know, primarily performance, but making it cost effective for customers as well. And so let's have a look at how the GreenButton addresses that. So we partner with ISVs, software vendors, to enable their platform, their software to run on our platform, and so they can take advantage of the scalability in the cloud. And we primarily target 5 vertical markets. Digital media, obviously, for films, animation, architectural designs, and photorealistic advertising media. Then we've got engineering for computational fluid dynamics, so if you want to design a wing for your Formula 1 car. Oil and gas for 3D seismic imaging, discovering where the next oil reservoir might be. And financial services for risk modeling of customers' portfolios and using Monte Carlo type simulations. And biotechnology for DNA sequencing and protein analysis. And the cost of getting your DNA sequence now is dramatically increasing, so soon you're about to rock up to a doctor, have your DNA sequence the next day and get highly specialised medicine, which is pretty damn cool. And so, as I said, we work with a software vendor to enable their software to run on our platform, and then we can deliver that to their end users and scale up thousands, tens of thousands of cores in the cloud. And we share the revenue with the software vendor as well, so it presents a new revenue stream for them rather than cannibalising their existing lucrative licensing model that they have in place today. And we manage the solution for them as well, so they don't have to worry about Azure subscriptions or the billing and that sort of thing. Cool, so I want to run through a brief trivial example. This is an example is 1 minute of animation, just so we can see how the costs stack up. And let's say on this 1 minute of animation, it's a frame rate of 30 frames a second, which is pretty conservative. Some films have been shot in up to 72 frames a second now, and then when you double that for 3D, it's 144 frames in every second of animation, which is crazy, good for us, I guess. So we have 1,800 frames, and let's say each of those frames is going to take an hour to render, which again is quite conservative. If we think of the Lord of the Rings films with the shots of Gollum in those frames, they took over 48 hours to render. So we have 1,800 hours of processing. The options we have to render this, let's say we're a one-man band, and we have our desktop sitting at home or in the office. It's going to take us 75 days. Woohoo! Guess it'll keep your house warm over winter. Cost about $1,500, give or take. The other option is we may be talking about a studio, and they may have a data center they want to invest in, and let's say they want the maximum performance in this case, so they're going to purchase 1,800 processors. So they can do that in about an hour, give or take. But the cost, well, at least $3.5 million to build a data center like that. You'd hope they're going to do more than their 1 minute of animation, but for the sake of this example. And the third option, yep, you guessed it, GreenButton. So we can also provision 1,800 cores, processors easily, get the job done in an hour, and for this particular example, we're looking at about $540. So we can see for a demand spiky workload, it's extremely cost effective rather than having a data center there that you're only going to utilize like 20% of the time or 30% of the time if you're lucky. So first demo, was anyone at the pre-keynote session yesterday on the dev track? Okay, so there is a bit of a crossover here, so bear with me. There's a couple of other things I'm going to show you, some of the other tools that customers can use.
Another option on that previous slide, same way they did prime numbers.
Yep. Yeah, just get everyone else to chip in and render your film for you. Not sure what's in it for them. Actually, there was I won't get too sidetracked, but there was a cool thing that Scott, our founder, was looking to do with Xbox, where they were going to render a film on it. And then I think the guys were going to get their credits added at the end of the film if the Xbox was used, but it didn't fly in the end. Cool. So we'll flick over. Cool, so we've been working with Pixar over the last little while. So most of us know Pixar as the animation studio behind Cars and Toy Story, but they're actually firstly a 25-year-old software company, and their rendering software, RenderMan, is used by all the top, the large studios for their animations and visual effects. And so, well, it is used by the top studios because, the stuff's pretty expensive at $2,500 a processor. And so in partnership with them, we've developed this cloud rendering service where customers don't have to worry about purchasing expensive software licenses or hardware and can just pay for this through a software as a service model. So there's a web portal where they'll come to run their RenderMan jobs. And we'll just go full screen. And logged in with my GreenButton user account. And so we'll go to the dashboard. And so here we have a list of the previous jobs I've run, and you can download any of the rendered outputs wherever I happen to be. But we'll kick off a new job. And so within this web interface, I can synchronize assets or files, assets as they call them in digital media, files up to the cloud that I'm going to need for this particular job. So for example, I can select this rib file. It's actually already cached in my user storage. And just out of interest, these, if you're interested, this is what a rib file looks like. It defines the geometry of what's going to be rendered. It's pretty hard to read. And references a bunch of other textures and shaders that are going to be used by RenderMan to actually produce the final output. And this rib file actually references a bunch of other files, and in complex cases, just for a single frame, you can sometimes reference tens of thousands of other files, and there could be gigabytes of data that need to be uploaded to the cloud. So what we have developed is, hopefully this application that's going to work, is this desktop application which we can give to the studios, and they could do general GreenButton stuff like, see their jobs I've run, download outputs, and but they can synchronize files and folders arbitrarily, or they can set up, Dropbox type watches, file watches. They can automatically synchronize a directory of, structured files with their cloud storage. But the application is these extensibility modules that we can pull into it for specific applications. And so in this case, for the RenderMan application, we have the ability to select one of these rib files, and it'll parse it for them, and it'll go and fish out all the assets that they have on the networks, shares, or wherever they happen to be, and they can upload those with the application, and it'll upload them in parallel so they get nice speedy uploads. And in this case, they're already cached, and they could kick the job off from here as well, so this tool's pretty useful for them. We'll flick back to here, and we'll go to step 2. And we'll select the rib file that we're going to render, in this case, magic.rib. It's already uploaded. Clever name tech, yeah, that'll do. And we'll kick that off. Got 2 of them. That's interesting. And so we're going to the details so we can preview the job running. And so what's happened here, this render is actually a single frame image rather than an animation. And so we split this up into smaller tiles, as we see here, and they're distributed across the many compute instances we have. And so in this case, we have 360 cores running up. And as each tile is complete, it's sent back via Azure Blob Storage so the user can see it on the website here. And for some reason, it actually kicked off 2 jobs then, so it's running half as fast as it should. Never seen that before. And so once the image is complete, once all the tiles are completed, it'll stitch them back together again in the right order, and the user can download the full resolution output, as we should see shortly. And so this render would normally take around half an hour, but over 30 minutes to run on a single machine. And so in this case, we're able to do that a lot quicker. We'll just wait for that to finish. We'll come back to it. So if we navigate to the dashboard that we have inside our website, yeah, we can see I ran 2 of them somehow. 30 of those a second, that's right. Yeah. And so, the problem pretty quickly compounds, which is, yeah. And so this particular job cost us 52 cents, so it's pretty cost effective in that sense when you're only paying for the millisecond that the job uses rather than having to worry about, how many hours have I had this virtual machine spun up in Windows Azure. And actually a cool feature in Windows Azure is if you spin up an instance 5 minutes before the hour and then close it down 5 minutes past the next hour, you actually pay 2 hours for that, even though you've only had it for 10 minutes. Nice. So another quick thing I want to show you is, we won't spend much time on it, but this is an interface we use internally, but we also give it to the software vendors so they can see how many users have signed up to use their product and how many jobs have run and the revenue share as well that they can see through the system, and they can drill down into particular job numbers. And we can also give them access to the parameters that the users are using within their application, so they get some insight into how users are using their software. So that's pretty powerful for them. Cool. So we'll flick back. Righty. We also have a Windows Phone 7 app, which I'm not going to show you from here because you won't be able to see anything. So we can enable applications very easily in hours. And how do we do this? Well, we have our SDK, and that's available to anyone to use to enable applications to run on Windows Azure. And it looks something like this. It's pretty busy. And so there's a couple of areas I want to highlight here. Firstly is the web services, which is highlighted in green. Hopefully you can see that. And that's the API that we expose to applications. And so we have a customer application on the left there, and it's talking to this API over either SOAP or REST, depending on what it wants to use. And then in the back end, we have three things that need to be enabled for a particular application: a job splitter, a VHD, and a task processor. And so the job splitter is an implementation of an interface, and it knows, given a particular job, how to split that into the granular tasks that can be parallelized. And so for an animation, let's say we've got 1,000 frames, it knows it's going to split that up into 1,000 tasks for each frame. And so this particular implementation is all around jobs that are called embarrassingly parallelizable, meaning they can be split up and worked on independently. The next thing is the VHD, virtual hard drive. And so this contains any executables that are required or any dependencies that are going to be kicked off to run the job. And thirdly, task processor implementation that will get given a particular task and will know how to kick off the executable in the VHD. And so it's a dynamic architecture in the sense that the web services that we spin up and then any virtual machines that we spin up to do the compute in the back end are completely generic. They load in these job splitter and task processor implementations at runtime. And so if we want to deploy a new application, all we do is just copy in a new assembly into blob storage, and it dynamically picks it up, and then we can run jobs through, which I will show you now. So how many people are developers in the room, coders? A good number. Oh, that's good. Great. All right. Well, there's a little bit of code, but for those of you who aren't developers, we're just not going to delve too deeply into the code. We'll keep it fairly conceptual. So let's have a look. So this application we're going to enable is called Deep Exploration, and that's used by companies like Boeing and Chrysler and SpaceX, and it takes in complex CAD models and can create photorealistic renders from them. It's pretty cool, like a Boeing engine you can pull apart and see all the internals of it. And so they use it for making training, photorealistic training guides, as well as advertising media. So in Visual Studio here, let's say we want to enable this deep exploration application with our SDK. As part of our SDK kit, we have a Visual Studio template. Got our project name. Cool. And not surprisingly, is what we see in here is a job splitter and a task processor that we can develop. And we have a reference to our Cloud SDK DLL, which has references to the log implementations and the interfaces that get implemented. So we'll have a look at the job splitter. So as I said, this is going to take in the key method here is split into tasks. It's going to take a job and return a list of tasks. And we'll firstly give this a name. So the application name is what references the virtual hard drive. So we mentioned before that we have a virtual hard drive with all the executables. So that's going to be called deepexploration.vhd, and that's what it's going to look for in blob storage. And the job type, in this case, it's going to be, what we're going to do is grab a single frame image and split that up into tiles like we saw in the RenderMan demo. And so we'd have an implementation for frames, and we'd also have a job splitter implementation for animations if we're going to go all that far with it. So we don't need to apply any custom configurations, so we'll remove that. Oops, and there's my little guy. There we go. So we'll just chuck some code in. Don't have to worry too much about what this is doing, but effectively what it's going to do is it's going to read in this XML file, which looks like this. And the key thing it needs to know is the width and the height of this particular image that's been submitted. So it knows when we're going to split it by 11 wide by 9 high, number of tiles, and so it needs to know how big each of the chunks is going to be, and it'll set, overwrite the XML for each of the tasks that we return with this chunk populated. That makes sense, hopefully. Cool, so we get the width attribute from the size in the XML, and then we calculate our chunk width by the number of chunks x, which is 11, and the width, and the same with the height. Cool, and this. Cool, and so what we're going to do now is loop around the x axes and then around the y axes, and just for each of these we're going to set the chunk attributes and then return a task for each of these. And as I said, we're just going to overwrite the XML for each task, so that task has the information about which the x and y coordinates that it's going to be rendering. And lastly, we're going to make sure I get this in the right place. With every job, we need to have a merge task at the end, and so the merge task we can do things like, if it's an animation, turn it into a video, or put everything into a zip archive. In this case, we're going to piece the image back together into the final image. Does that all make sense? Yep. Cool. All right, let's copy that, save me typing. Solution navigator. So the task processor, we'll populate that now quickly. And there are a bunch of methods at the start here, like the framework does a lot of the stuff for us. Like when it mounts the virtual hard drive, it's going to set the drive letter for us, and so it'll inject that into the implementation for us. So I'm just going to overwrite these methods at the start and not dwell on them too much. That is essentially helpful methods that are used by the framework for us, like the name of the results file. But the interesting methods are this run external task process. So this is given a particular task, and if we have a look at the code for that. So this is going to execute this de-hdr-render.executable, which is the guy that's going to do the processing for us. And if we look at what's in this VHD, you'll see, not surprisingly, we have a deep exploration folder, and here's the executable that we're going to run. So this is the VHD package for this particular application. And we have this untiler application here as well, which will stitch it back together. Cool, and then effectively we run the process with the arguments that we're going to pass in, and we return the output at the end there. And this output, we can return any number of files. We can return log files, thumbnail previews, and we can essentially just list them there and return them, and they can be used by the front-end application for whatever they want to be doing with it. Cool, and the last interesting method is the merge. And so that's kicking off this untiler. It just gives it the path to where the local storage, where all the files are going to reside. And so the framework is responsible for downloading all the required files to local storage before we kick off any tasks. And so when we're in the task processor here, we can assume that everything's already there for us, and all we have to do is initiate the executable. Return the output, and again, there's a bunch of helper methods here at the end, which we'll just overwrite. And make sure we get our namespaces. Come on. Cool. We'll set that to release. Give it a compile. And now all we do grab all of this stuff, zip it up. Yep, looks good. We go into the Storage Explorer, and so this is navigating within the storage account that we're using for this deployment. And if we go to the GreenButton Cloud Assemblies, that's where all the enabled applications will live. And so we can just dump this guy into here. And then all the web services that I got spun up for this and all the VMs that I have spun up will automatically pick this up. And here in the cloud drives container is where the VHD lives. So I've already uploaded that for us because that's 70 megabytes. Cool. So if we actually go to deep exploration now, this resolution is not too friendly on us, but so this is what the application looks like, and I've got this model open of a F250. And so we've got a couple of options when we run a job prediction or advanced, and I'll just kick the job off and then talk about those a little bit while it's doing its compression and everything. So the job prediction we see as a bit of a game changer. We put every application through a life cycle where we start collecting every single job information, all the information about every job, and then we've got these training algorithms that we run against the data, and we slowly reduce the size of the bell curve. And so the more data we get, the more accurate it becomes. And once it gets to a point where we're fairly confident with the data set, then we put that out there on the market, and that'll profile a user's job when we run it up, and then it'll put that result into our commercial engine, which will give the user options as to how they want to run their job. And so if they don't need it particularly fast, then they can select the slower, cheaper option, but if they want it back extremely fast, like now, then they can pay a little more for it. And we make an SLA to the user around it as well, so we cap the price at the price that we quote for them, and we also make a commitment on the time that we quote for them as well. So I think that's pretty cool. So this is just uploading one asset one file that it needs to synchronize. Hopefully our bandwidth is working all right. Oh, yep, not bad. Cool, and the job is submitted. And so the resolution for this particular image, if we go to the properties within the application, is set here, so 1200 by 600. And so this GreenButton implementation here is probably more typical of how we'd integrate the GreenButton with an application as opposed to the website we saw earlier. Here everything is nicely integrated into the application for the user. All they have to do is click a button and their job's uploaded. If we go here, let's make sure this guy's actually running right for us. Okay, so this application here, I forgot to show you earlier. It's called Mission Control, and this is something we use internally, and it's a prototype application, and built as a bit of a proof of concept, and that's why it looks really ugly in this resolution. Doesn't like it at all. In fact, the developer who built this, if he knew I was showing you guys at a TechEd presentation, he'd probably die. But this is what we use to manage jobs, and we can see this job is coming here, and we split it into the 11 by 9 tiles that we said earlier, and so we've got 99 tasks. And in the bottom view here, we can see all the individual tasks that have been rendered, and so we can see all the unique virtual machine identifiers in Windows Azure that are doing the work. And we can see here that they're quad-core machines as well. And this charge time here is the number of milliseconds that we're calculating to aggregating for each task that's been run up. And so we aggregate that for the job, and that's what the user pays. And what we can also do is drill into, that one's not doing anything. We can drill into a particular virtual machine ID and see live information, live logs from that particular VM. So it's a bit of a window into the cloud and really useful for diagnosing what's going on. And we can also see a list of all the VMs that we have and see what CPU the they're sitting on and if they're working on a job and stuff. So the plan with this is to rebuild this in HTML5 as a web app, and then we can give this to software vendors and also customers as well, and so they can see just the relevant bit of information about what they're doing. So we think that'll be pretty cool. So if there's any good HTML5 developers out there, come and see me. Cool, so we'll go back to here. So this is the full resolution. Well, it goes a lot bigger than that, but that's the final image, which is pretty cool. So that is deep exploration. Let's flip back. So there you go, it's pretty easy to enable a new application with our SDK. So let's take a little bit more of a look at the architecture. And this diagram I'm going to throw up, just warn you, you might not be able to read all of it. It's pretty small. Actually, all the small white writing just says lorem ipsum a bunch of times. So just imagine it's something useful. But the key thing I want to talk to in this diagram is that the architecture is actually cloud agnostic. You know, we run up on Windows Azure today, but we may want to run up on other cloud platforms in the future. You know, the certain job might have characteristics associated with it that maybe lend itself to a platform that supports Linux, or there may be a public data set like some Bloomberg feed that we want to send some financial analysis to. And so the way we make it cloud agnostic is by using a dependency injection pattern. Are people familiar with that? Yeah. And so you know, it's a very simple and powerful design pattern. And so all the core framework stuff in the middle here and all the GreenButton services are completely generic to any cloud implementation. You know, the ability to scale up for new jobs, the ability to prioritize all those jobs. You know, it doesn't care what cloud it is. And so down the bottom layer here we have you know, the management API that we use to scale up and down, and the storage adapter layer, so the ability to talk to tables, queues, and blobs. So that's the cloud-specific stuff. And so we just configure in those concrete implementations when we deploy. It also aids testability, so I think it's a really solid practice to use anyway. You know, we can test each layer of our code in isolation. And it's multi-tenant architecture in that it's designed to support any number of different applications or software vendors that we saw, and also any number of users for those applications. Well, maybe not any number, but hopefully enough. This is another bit of software we're developing. This product, essentially we're productizing our GreenButton software capability that runs in the cloud. And so an organization could pick that up and run that on their private cloud internally, and then using configurable rules around maybe utilization of their internal data center and time of day, it can burst out into the public cloud. So we see the sort of on-premise on the left and public cloud on the right there. And so an example of this is for a financial institution where they may have, you know, a heavy trading day and they need to, you know, do some initial analysis to get their end of days done, or they want to test out some new models or something like that. So it's just a bit of a walkthrough of how a job goes through our system and how we scale up. And firstly, embarrassingly parallelizable jobs, so animations as we saw earlier, embarrassingly parallelizable. So a job comes in, we split it into tasks as we saw, and those are placed on a queue for the job. And we actually use queues quite heavily. So a single job may have a number of queues, and we use them to manage the workflow or dependencies that a particular job might have. And then our resource controller that lives in a worker role sits there monitoring all the jobs constantly and scales up and down as required. So it'll spin up new instances if needed. And it also keeps an eye on things like the wall clock, and so it won't spin up a bunch of instances, you know, a couple of minutes before the hour, which is not going to be very cost effective for us. And if it spins up instances for a job, it'll also leave them up and running until the end of the hour. The other type of workload we support is message passing interface jobs, or MPI jobs. Anyone familiar with what they are? Yep. So the difference is, I guess, they're not embarrassingly parallelizable. And so in this case, the MPI framework, or message passing interface framework, is responsible for running this job. And so what we do is provision a cluster for it and hand off the job to it. And what these frameworks do is the head node will distribute little bits of data out to the worker nodes who will do the actual calculation, and then it'll get the results back and aggregate them before moving on to the next piece. Cool. So next quick demo is on auto-scaling. And so you can do a bunch of useful things with the management API. You can automatically deploy and run your system tests. I'm sure all of us have got a comprehensive suite of programmatic system tests. But we obviously use it for scaling up and down the instances. And you can also use the Azure commandlets. There's a bunch of PowerShell commandlets you can use to do the same thing. And so it really depends on what works best for your scenario. Right. So what we're going to do here is we're going to monitor CPU load. And when it gets to a certain threshold, we're going to scale up, increment the number of instances we have in Azure. It's a little bit backwards and useless because we're going to be monitoring the CPU on my computer and then scaling up in Azure, which isn't really going to achieve much, but we'll still get the idea. So firstly, we need to know some stuff about where we're going in Windows Azure. So we have our identifier for the Azure subscription, and we have a certificate thumbprint. So anytime you're doing anything with the management API, you need to have a certificate to authenticate that you're who you are. And you upload these inside the Windows Azure portal. And then you need to make sure it's installed on the machine that you're running from, obviously. And this is the name of the role that we're going to scale up. And this is the hosted service that the role is deployed to. How many people are actually doing anything with Azure today? OK, cool. Well, I'll try not to assume too much knowledge. Cool, and so we set up a performance counter and set our threshold of when we're going to scale, and we want to average that over 10 readings because we don't want it to react too fast. And so we get our next value, and once it cracks the threshold, then we're going to call into this Azure Instance Manager. So we'll run this up. Cool. Actually, I closed Deep Exploration, which I was going to use to generate some CPU for me. So what I'll just do is decrease the threshold because I don't really need that. Cool, so we're pretty quickly going to crack our threshold once the 10 readings are done. Cool, so we'll step into this initializer. And firstly, well, let's have a little look at the structure of this project. We have just a console application, which we can see. This other project that I referenced has all the code that knows how to talk to the management API, and it's got some entities and input parameters. And this is actually standard code off MSDN that you can go and grab. So we're just using the standard stuff here. So the first thing we'll do is grab our certificate. So we just query the X509 certificate store. In Windows Azure, this needs to be set to local machine rather than current user. And we'll just get the one for the thumbprint we're after. So we've got that. And the other thing we're going to set is our retry policy. And I'll talk a little bit about this some more later. Everything you do in the cloud, we need to have retries because stuff fails a bit more frequently than we might like. And so we need to set how we're going to retry, which is cool. Cool, so the first thing we need to do is get a channel that we're going to use to communicate with the management API. So flick around there, and so we'll skip over that. So it's a REST API, so we're going to create a web HTTP binding. And we're going to tell it that we're going to authenticate using certificates. And then we need to create this factory, which this interface here defines the operations that the channel is going to support. And so these are all the operations you can perform through the management API, that's similar to the operations you perform through the portal. So, begin, delete deployment, end delete deployment. Cool, so we get our factory. We need to add this behavior, which is just going to inject in some version header name and information, just to authenticate. Pass in our certificate, and we'll create our channel. Cool, and so we're going to try and find our deployment, and my fingers are crossed because for some reason in TechEd New Zealand this decided to fail, and it's never failed for me any other time, so I'm not even sure why. I didn't actually debug it on stage. Come on, demo gods. Hey, it worked. I shouldn't have told you it failed. So we get back our deployment, and we can see information about, it's in the production slot. We can see we've got 2 instances, they're running, this is where they live. Cool, so we'll step through that. So what we do to change the configuration or to increase the number of instances is we just grab the configuration that is currently deployed, which we got back as part of the deployment object. And so we can see here the configuration. And so the key thing we care about here is this number of instances. So we'll pull that bit of information out, just increment it by 1. So our new instance count is going to be 3. And then we just do a change configuration call with our new configuration. And if we quickly flick over to the Azure portal, that's not the Azure portal. Oh, yep, it is. This is our deployment here with 2 processes, 2 worker roles at the moment. Hopefully we shall see that increase. So you can see here we're just cycling using the operation identifier to constantly check back through the management API just to check what's happening with the operation. And so we might want to time out after a while. And so you can see down the bottom here we're about to refresh. And one would hope that we will see something go on. Oh, here we go. That's positive. And so it's pretty easy. I mean, those who've worked with Windows Azure will know the unfortunate thing is it takes about 15 minutes for the new instances to start up, which can be a little bit painful. It limits what sort of customers we can, or jobs we can take on. Customers who say we want to submit jobs and scale up to 100 instances and have that back in 5 minutes. That would be nice. And so typically what we do is for rendering jobs, we have a pool of instances always running, so the users get some sort of responsiveness, and then we scale up in the back end. And so, if the jobs take longer than half an hour, then that's really the ideal. Come on. Hey, here we go. We have a new instance. Cool. So that should help the CPU on my laptop. Right. So that's that. Switch back. How are we doing for time? For some reason, I decided to develop this demo last night. I thought it'd be quite a useful demonstration. So it's a bit risque, but you guys interested in seeing this? How you create a VPN from the cloud on-premise? And so the example I'm going to show is actually connecting from a website in Azure, connecting to my SQL Server on my laptop. Question? Can you, using the Connect? Yeah, you can configure up, as I'll show you, you can configure up to say that these roles can talk to each other. But you have to open up particular ports before you deploy your role, which I can show you afterwards if you want. It's pretty easy to configure up. But yeah, the firewall's locked down on all the VMs that you deploy. So let's have a quick look at it anyway. It won't take long because it's all actually deployed and working. All right, I'll definitely reference my notes for this one. So Azure Connect is, as I mentioned, is so you can connect back to your on-premise data center. You specify particular computers or servers that you want to provide access to. And so how you do that is through this virtual network option here. And we'll select a subscription. And so the first thing you need to do, or one of the first things, is to install this bit of software on the server that you want to connect to on your data center. And so ideally you can just run this from your server, but if your security policy doesn't allow you to do that, then there's a standalone installation you can use. And so we install that on the server, and then we get this activation token. And so we generate a token for each subscription. Oh, there we go, our thing's still running. Let's close that down. Don't need you anymore. So we grab this token from here, and then in the role, the Azure role that we're about to deploy, in the configuration for it, so this is my Azure service here, and we've got a simple is a simple web role, so an ASP.NET application. And if you go into here, in the properties of the role is the virtual network. So we just paste in the token into there. The web config. So in here, we can see in the connection strings, this is referencing my laptop. And actually, one thing that tripped me up for a little while is you have to specify the port. By putting the comma in the port after it, it specifies it's going to use TCP IP protocol. And so you need to make sure that's enabled on your SQL Server, obviously. And then all I've done is, in the page load, I'm just connecting to the database, selecting a value from the table, and then setting that on the welcome page, on the home page. And if we have a quick look, it just looks like that. Oops. Welcome, TechEd. And so we deploy that out, and then once that's in Azure, the next thing we have to do is configure those roles so they can talk to each other, those endpoints. So if we look in here at the groups, we have this TechEd group which I've created. And when you go edit, so when you go and you create a new group, so the things can talk to each other, and you go add, you'll see a list of any servers that have been had the connection utility installed in it. And then in the bottom here is any roles which have the thing enabled that we just saw in the project. So you add those, and there's the connection you're asking about. There's setting about how you allow the roles to communicate between each other. Cool, and then as we'll see, we've timed out. Cool, let's hit that again. Actually, one thing I wanted to, I was going to RDP, you can remote into Azure machines, but I won't bother with that in the interest of time. So here we go, and all I want to do is change the value that this is reading, just to prove that it is in fact reading from my laptop. Hey, there we go. So that's that role living out in Windows Azure, and we're pretty easily able to configure that up. So that wasn't a very hands-on demo, but hopefully it'll show you it is fairly easy to set up, and this may work for if you're trying to move existing applications into the cloud, but you have some restrictions on what you can and can't move. This could be quite a useful piece of technology. There's a slight flaw in this implementation because every time I turn the laptop off, this lovely website fails. Never mind. Any questions on that? I know we just breezed through it pretty quickly. Nope. Cool. Yep.
Is that the C# class we use for the management piece?
Yeah.
Are they something you construct yourself based on Unity, Docker?
No, pretty much everything as you saw it there, you can download and just use out of the box. So yeah, none of that has been tweaked or edited. Yeah, I can find the link out for you if you want.
Well, if you want, you can use the server crawler command and do that via PowerShell.
Yeah, as I mentioned before, if you don't want to do it programmatically or want to do it from PowerShell, you can do that. Like if you want to integrate it into your continuous integration, then the commandlets are probably the better approach because you can just kick those PowerShell commandlets off. Cool, so we're up in Redmond a few days or a couple of weeks ago, and we're doing some scalability testing there with the Azure and App Fabric guys. And I'm quite surprised that when we deployed out a reasonably large number of instances, that a certain percentage of them just would go into what we call zombie state, or zombie instances. And they just sit there indefinitely, just cycling through the different statuses that they have, and they wouldn't come up. And it's nothing to do with our code, well, that's what I reckon. But it's something that the Fabric controller in Azure just will do sometimes for a laugh. And so you need to be aware that Azure does stuff for a laugh sometimes. And there was a really, really funny moment, Christmas Day, when Azure decided to bring our live website down. And so I was down in the Marlborough Sounds in New Zealand in the yacht with my 3G dongle trying to work out what the hell was going on. And so it's good to be aware of this, and I guess that comes down to my second point there, that instances in Azure, you've got to treat them as volatile, and so your architecture needs to cater for that. The instances are going to get upgraded or patched without you knowing, so you need to be careful how you manage state and make sure you have that high availability built into the architecture. make sure you have the last laugh. So some insights into storage. Is anyone familiar with NoSQL? I'm sure most of the developers are these days, yeah. So NoSQL actually stands for not only SQL, I believe. And so what it's talking about is not just using relational data storage. And so when we move our applications to the cloud, we've got other options for how we store data. And so Azure Table Storage is an example of a NoSQL type of storage where you don't have relationships with the data, it's just arbitrary entities that you store. And the advantage here is it's designed to be highly scalable, like extremely highly scalable. And so you define partition for your data, and then Windows Azure will automatically scale out the data depending on where the hotspots are. And if you have billions of records, then it'll manage to scale out for it. Whereas if you want to try and shard in SQL Azure, then that's going to be a little more difficult. There's also a massive cost differential. SQL Azure is $9.99 for a gigabyte a month, whereas Azure Table Storage is 15 cents a gigabyte a month. So there's definitely benefits there. Relating to, one of the things we definitely learned moving to the cloud is it's a bit harder to look into the cloud. And there's definite scalability limits, particularly around storage accounts that we'll touch on. And so it's very important that you can measure everything in your architecture and know exactly where those bottlenecks are. And what we found is an interesting approach to the scalability side of it is to treat our entire architecture as a scale unit. And so we know, for example, how many users we can support with 2 web services, how many worker nodes we can support with 1 controller instance. And so when we need to support more throughput, then we know we can scale everything in proportion. If you just scale one at a time, then you're just moving the bottlenecks around. And so Azure Storage scalability, the accounts have a fairly rigid scalability limit of around 500 transactions a second. And it can be less, just depending on what Azure's up to that day. And so quite a useful thing to build into your architecture is the ability to shard across multiple storage accounts. So customers with first letters A to E can go on one storage account, F to J in another. And that's something I wish we'd thought about earlier and something we're sort of working into our architecture now. And so what happens when you reach your scalability limit is you get throttled by Azure, which isn't a nice thing to happen. And so that comes on to the next point, and that's around retry logic. And I mentioned before, everything you do on the cloud, you have to assume is going to fail. You have these transient error conditions, which are essentially temporary errors or temporary conditions that are causing an error. And so you have to know which exceptions are transient and which aren't. And if they are transient, then you need to retry, and you need to have some logic about how you back off when you retry. So you retry quickly, and then you back off a little bit longer and back off a little bit longer until you eventually time out. And that's quite hard to get right, depending on what you're talking to, whether it's a service bus or tables or SQL Azure. You want different back off times. And so fortunately, these smart guys, the Azure CAT team, Customer Advisory Team, used to be the App Fabric CAT team. They've written a framework called the Transient Fault Handling Framework. And this is production-ready code that you can just pick up and use. So anyone who's going to do Azure development, I really strongly recommend grabbing this right from the get-go. It will save you a lot of pain. High-performance computing in the cloud. So just a couple of quick points. So some people still debate whether the cloud is an appropriate place for high-performance computing. There's customers out there who, companies who have spent millions and millions of dollars fine-tuning their data centers to optimize their algorithms and run them in the most performant manner. But that really comes down to the second point, that it's all relative to, cost is relative to performance, or vice versa. So some workloads probably aren't the best fit for the cloud today, if they're really I/O bound. But we're seeing with the cloud players like Amazon have their high-performance computing-focused hardware that you can provision, and I'd be surprised if we didn't see something similar from Microsoft as well. And as we saw earlier, for spiky type of workloads, the cost savings can be huge. So it definitely resonates with the customers that we're dealing with. So to quickly summarize, we saw the problems with high-performance computing that customers have out there, and cost and complexity and performance. Saw how the GreenButton solution works with the 5 different vertical markets that we're targeting, the cloud-agnostic architecture, the cost example, and how we enable applications with the SDK fairly easily, and how our scaling solution works. So there we go, the power of a supercomputer from your desktop. Well, I hope that's been useful. Are there the mandatory slides about winning stuff and getting your evals in, which is always appreciated. So, any questions? Yep, that was quick.
So, your data centre got set up with unusual circumstances. So
Yes.
I assume this sort of got a reasonable price. So, is your next challenge being able to make it viable so that in the next phase of maintenance upgrade and hardware upgrade and all that's going to be...
Well, because we're running 100% in Windows Azure now, that problem's completely taken away from us. So, Microsoft have their hardware refresh cycle, which is, I think, 3 years or something. So our old data center that we had out of the wetter days has all been more or less decommissioned now.
Oh, it's already been done.
Yeah. So that kit's pretty old in the tooth now. Yeah.
Obviously, to get the rendering processing sort of stuff into the cloud, you need some API support for Azure and the shared workload stuff. Are there any other solutions other than RenderMan that you're aware of that the site has having that capability? For example, like your Adobe products?
Yeah, well, we've got a number of rendering platforms already enabled on our system. So Blender, 3ds Max, V-Ray, Maxwell, a few others. So we are working through the list. But yeah, so I mean, if there are specific ones that you have in mind, then talk to us. And with our smart developer Anna back home, she can whip up these applications and enable them in days sometimes. So, yeah. Yep.
How long did it take for you to migrate your existing systems from Linux to run in Azure?
Yeah, well, that's when I joined, and it was a complete. I hardly even looked at what was in the Linux system because it was built on a shoestring, and so my job was to build a new architecture and make it cloud agnostic. And so it was probably we launched publicly in October last year, and we probably started development around June. So. We had stuff up and running probably within about a month, and then we just sort of continued to refine things and move along. Yeah.
I just wanted to say the point about the instances not starting up.
Yep.
You're not alone. We have exactly the same.
Yeah. It sort of comes and goes in waves. Sometimes it can be pretty well behaved, and other times it can be like, man, I've got like 50% of these if I'm lucky. Yeah.
And just one question as well. What development processes do you use to get this stuff up in a month? Do you use Scrum-based or waterfall?
Yeah, I actually I put a slide in here after my New Zealand talk about that, but I took it out. We use Scrum, and we have weekly sprints. And the problem we have is the priorities change so quickly. We get a new opportunity, Pixar or something, and they comes along, and it's like, the number one priority today. And so we have to evolve pretty quickly. And what we actually do is we don't do any estimation, no formal estimation of any requirements. And so everyone's extremely motivated and productive as they are. So we try and remove any extra any extra overhead with the process itself. And we have quite a rigid process around our continuous integration. So we have our unit tests, which test only the code and don't touch any Azure or any web services. And then we have our integration tests, which hit the storage endpoints and the management API. And then our system tests, which run everything end-to-end as a user would. And so we automatically deploy to Windows Azure every evening, run our suite of system tests and make sure they run through. It gets quite difficult because, for one particular application, you may have a suite of different, peculiar curly scenarios that'll throw up errors. And so trying to run all those tests, overnight can be quite challenging sometimes. Anything else? Yep. Yeah, it's a good question. That's it's something that I'm wanting to develop as a little emulator that you can run up to test it. At the moment, we don't, but we'd happily run up code, or anyone who wants to use the SDK, we tend to work pretty closely with and help them along. And at this stage, but hopefully soon.
Moving to Azure, did you find the costs from having your own data center to cloud? What kind of cost savings did you get?
Well.
Other reasons
Good questions. Our actual costs are more because back then we weren't really paying for the on-premise data center, but now all our development and all our testing and beta testing is all in Azure, so we have to pay for all of that. So there's a lot of stuff that we run up that isn't for customers' jobs, and so we have to sort of be careful about that. But for the actual, so yeah, I hope that answers your question, but I think, yeah, we have to try and be careful about what we actually run in the cloud from a development point of view and what we can just run locally. And Microsoft help us out with beta testing and things like if we're launching a new application and we're beta testing, say, the Pixar project, then they help us out a little bit there, which is nice. Nice guys. Anything else?
If anyone's interested, I've got some PowerShell scripts that I'm willing to share on the website running deployments.
Yep.
And just an aspect in regards to instances, sometimes one coming up. We've done some investigation, found Azure diagnostics, and sometimes have these handles on patch numbers and diagnostic files.
Yeah, yeah.
Which of course is kind of blocking contention.
Right, yeah.
So we have a workaround for that as well. It's on Taylor Martin's blog, for those of you that may know him, in regards to stabilizing work.
Okay. Oh, maybe if you share that information with me. And actually, I just realised I haven't got my contact details in this slide, so I'll put them up on this other one. And yeah, if you share that with me, and these guys can take my contact details. There we go. Anything else? Very attentive crowd. Thanks. So that's my details there. So feel free to email me, and if you want to further discuss what I've shown you, or if you want any of the code, I'm happy to share that. Cool. Thanks.